Assalamualaikum warahmatullahi wabarakatuh and good morning. So today I will share a video about how to calculate the exponential value by using the Euler Theorem. So this is a link to use the calculator software, and the good news is we can use this software for free within the PKP period. Okay, first you need to check and find your calculator version. So in my case, my version is FX570EX. So download and install in your PC. Okay, before we start, we need to change the mode. Change the mode from D if your mode of calculator is in degree mode. We need to change to radian mode so that we can use the pi without changing it into 180 degree. Okay, so you can choose the shift menu and then choose the number 2 for angle unit. And since our calculator mode is in degree, we need to change to radian, so choose 2, and you can see here it is changed to radian. Next is we need to change to complex number. So if your calculator is not does not show the I alphabet here, so you need to change to the complex number, which is the real with imaginary number. So to change it, you just choose the menu and then choose the number 2, which is the complex number. So it will display the icon of imaginary. Okay, let's continue with the example. So to calculate the exponential value, as we can see here, exponent j theta, theta is our phase, alright? So to calculate the ej theta, we can use the cos and sine, which is stated in the Euler identity, cos theta plus j sine theta. If we have exponent negative j theta, our operation here will change to negative. Okay, it becomes cos theta minus j sine theta, and j to the power of 2 is equal to negative 1. This one we need to memorize the Euler identity, and also the j to the power of 2 is negative 1. Right, so let's see an example here. Our theta is equal to 3 pi, and another example is the theta is equal to 3 pi over 2. So first we write down the equation of the Euler, which is cos theta minus j sine theta, and in our case the theta is 3 pi, just put the 3 pi at the theta. And since our theta is negative j in the negative form, so our operation must be minus here. So we can just use this equation in our calculator. So we can write the cos 3 pi shift pi minus I sine 3 pi. So the answer will be negative 1. Right, you just write down all the equation and you will get automatic the final answer. Next is our value that we need to calculate is 2 exponent negative j 3 pi over 2. Right, so we can change here. So we have the amplitude 2 times cos 3 pi over 2 minus I sine 3 pi over 2. And then the answer will be 2i. Okay, there is option for you to calculate one by one. Find the cos 3 pi over 2 and you get 0. And next is find the sine 3 pi over 2 and the value is -1. And then you calculate all the equation here. Another way is just key in all the equation here in the calculator and you can get a final answer. Okay, let's see another example. So for example, you need to find the value of the discrete Fourier transform of the given discrete signal. So this is the equation to find the DFT signal, which is we need to find the summation of discrete signal times with exponent -j 2 pi n k over n capital from n equals to 0 until the number of sample -1. So this is the solution. This is the equation for finding the DFT. And we need to calculate from xDFT0 until xDFT3. Okay, first we need to calculate the xDFT0. So to find the xDFT0, we just use this equation and change the k here to the value of 0, which is the one that we want to find. So exponent 0 for this case is 1. That's why we will calculate the summation of x0, x1, x2 and x3, which is 1 plus 2 plus 1 plus 0. And the answer will be 4. Next is we need to calculate the k equals to 1 to find the value of xDFT1. So this is the equation. The summation of the exponent -j 2 pi n, and in our case k is equal to 1, and multiply with the discrete signal. Okay, let's see how we can calculate 1 plus 2 exponent -j pi over 2 is equal to cos pi over 2 minus, because our j is negative form, so minus I sine pi over 2. Okay, plus for this equation we have cos pi minus, so this is minus I sine pi. So the answer will be -2i. Okay, right? So you can try at home how to calculate the k equals to 2 and also xDFT3, right? When the k is equal to 3, and the final answer will be 4 -j2 0 j2. So you can just key in all the equation here in the calculator and get the final answer, so that it will save you time to key in one by one. So how about if we have a long value of k that we need to find, for example from 0 until 6 with 7 number of samples. So given xn equals to 1, 4, 6, 4, 1, 0, 0, so how can we find the DFT k in a faster way? So To use the calculator, we can use the option button and use the variable a for the equation. The a stands for the k value, so we can change the k. So we can use the option button in the calculator to calculate all the value of n, because this is the summation of discrete signal with multiplication of exponential from the n equals to 0, the discrete signal from 0 until 6. So this is a long equation, so we can use the calculator to write all the equation and then just change the value of a. So for example, k equals to 0, and then you can get the answer in a fast way. And then we just change the a equals to 1 until 6 and you will get the answer. Okay, so let's try using the calculator. Right, so we can just key in the equation here. 1 plus 4 times cos 2 pi to the alpha a divided by 7 minus I sine 2 pi alpha a divided by 7 okay, this is for this equation, and we need to key in until the last equation here. Okay, after finish keying all the equation, we can find the value of k equals to 0 until 6 by using the calculate button, and we can choose the a value. For example, 0. So is 0, the answer will be 16, and then put the choose the calculate CALC button and use the a equals to 1, and the answer will be negative 2.35 minus j 10.28. And for example, we want to find the k equals to 5, calculate 5, and the value will be negative 2.18 minus j 1.05. Okay, that's all for the video. Hope all of you can try the calculator. Thank you for watching the video.